Right. Good day, guys. I hope you're doing very well. I'm for the for the first time today, I've noticed that I can actually see who's signing in and when you're signing in. So welcome to all the regulars, and it's really good to see you. Hope you're all doing well. All right. So I'm very happy that we have the lovely Miss Mel as our co-host. She makes sure that none of the tech mishaps happen. I just told her something that just happened. I have a tutor class at the end of the day at 2, and I didn't realize my video was on. So I was looking on my phone, doing things in the study while I was listening to the girls, because I work at a girls' school, talk about their day, and only realized way too late that my video is still on, and it's not great. So I'm very happy that we have the lovely Mrs. Mel to help us organize all the tech stuff. So today we are going to just look at the structure of the inner ear. So yesterday we learned more about the outside ear and the middle ear. Today we will look at the structure of the inner ear. And again, there's a lot of detail. There's not a lot of understanding work. Hearing is understanding, but to know the structure of the ear, you need to study. So I will keep the notes up a little bit. If I go too fast, just ask me to slow down. I'll bring the chats up and we can do that. And then we are going to learn how hearing works. How do you hear? The process of hearing. Oops, process of hearing. And then we will do a little Kahoot in the end if there's time. So let's start. So for hearing, or the inner ear, you need to know all the anatomy. You need to know the parts of the inner ear as well as their function. You also need to understand hearing. So how does your ear hear, including the role of the organ of Corti. You don't need to know the details of the structure. You just need to know that how hearing works. And then tomorrow we will look at balance and middle ear infection and deafness. And then we'll answer exam style questions tomorrow. So just a little bit of a recap from yesterday. You have your outer ear. It's made up of that little fleshy cartilage flap called the pinna, and that catches the sound waves and it directs the sound waves into your ear canal. Remember, anytime you see the word auditory, you need to think of hearing. So this is also known as the auditory canal. Then you have your tympanic membrane, and that is all that's known as the eardrum. And we have the ossicles. The ossicles are the smallest bones in your body, and we have the hammer, the anvil, and the stirrup. So today we will look at the inner ear. The inner ear is in the skull. It's protected by the skull, and we'll learn a little bit more about the structure of the inner ear, as well as the eustachian tube, what the eustachian tube's function is. All right, remember to post your questions in the chat, and then I'll get to them if we have a little bit of time in between questions or there's time at the end. All right, so the semicircular canals, here you have 3 semicircular canals, and they all point in different directions, which helps with the hearing. You have your vestibule, and then you have your cochlea. It's kind of in the shape of a snail. The whole inner ear looks like a fancy snail to me. Here you have the shell, the body of the snail, and then the head. It's the 3 semicircular canals, your vestibule, and your cochlea. This is the stirrup, the round window, and the oval window, and that's still part of the middle ear. So let's learn a bit about the parts. So you have your semicircular canals, and I just inserted that little picture because it helps to show us exactly where it is in relationship to the others. So your semicircular canals are arranged at right angles of each other, so they are all pointing in different directions. They are located above the vestibule, and each canal has an enlarged area called the ampulla. At one end, and inside the ampulla are the receptors. So you have your little loop, and then at the end of the loop, you have your ampulla. And inside your ampulla, you have your crista. Now the crista is what we use to hear. They detect the change in speed and direction, and they generate impulses to send to the cerebellum. So this is where hearing happens. So you have your 3 semicircular canals, and they all point in different directions. They are at right angles to each other. So they all point into different directions. And the function of this is to help us to detect change in speed and direction. So if you twist your head around, the crista detect the change in speed and direction of your head. And it also generates the impulses sent to the cerebellum. Okay, then we have your vestibule. Your vestibule is right below the ampulla. It's right below the ampulla. And it's made up of 2 membranous sacs called the succulus and the utriculus. And they are both filled with endolymph. So endo means inside. Inside each are receptors called the macula, and the macula have tiny hair cells covered with a jelly-like substance and tiny calcium carbonate stones. So I'm going to leave that on a little bit because yesterday I was too fast and people were making notes. Oh my gosh. So, I mean, I've had a very long day of saying the wrong things. So the ampulla of the semicircular canals are just for balance. So if you twist your head around or you move your body, it tells you where you are in space. So it helps with balance and finding your space. Hearing is in the cochlea. So let's go back to the vestibule. Your vestibule is the 2 membranous sacs. So membranous just means it's fluid filled, it's filled with endolymph, and inside are the receptors called the macula. The macula have tiny hair cells, and if you remember those little purple cells I showed you yesterday, those are the tiny hair cells. They're covered with a jelly-like substance, and they've got tiny calcium carbonate stones. These receptors detect change in the position of the head with respect to gravity. So the vestibules and your canals help with balance, and it helps you to place yourself in relation to whatever is around you. And now we come to the place where hearing happens. So hearing happens in the little shell of the snail, in the cochlea. It's divided into 3 chambers. So it's divided into 3 little chambers. And each chamber is filled. So the upper and lower chambers are filled with perilymph. The middle chamber is filled with endolymph, and it's got the organ of Corti. So remember, you don't need to know the exact details of this. You just need to know the basics. So you need to know that the cochlea is divided into 3 chambers. You've got the upper and lower chamber that is filled with perilymph. And then you've got your endolymph in the middle. And it's also the middle chamber also has the organ of Corti. And that organ of Corti has got tiny, tiny hairs embedded in the membrane. And the organ of Corti is where all the sound is interpreted. Remember, like sight, your retina just get light waves, and then it is changed into an impulse and sent to the brain. The same for sound. Your organ of Corti is the receptor responsible for interpreting sound, and it converts the stimulus of sound into an impulse. So that impulse is then sent through your auditory nerve to your brain, where it is interpreted in the cerebrum. Okay, so I'm going to leave this on. I'm going to quickly see if there's any chat or any questions. There's one. Thank you, Carl Henry. So there's a Yeah, Bob, you're right. I just had a bit of a lapse there, a brain fart. The semicircular canals are just for balance. The cochlea is where hearing happens. All right, so if you're all fine with the anatomy, we're going to quickly go to some videos. Now, the problem with videos is if it is copyrighted, we can't always play it on here. So we have to go to a place that is copyright free or that isn't owned by people who actually sell their product for money. So we also had to make sure that everything is copyright free. So we're going to go back to this because this was a really good video to show the inner ear and the parts of the inner ear. We're going to zoom in into the inner ear. So I'll add this link in. Here you have your 3 canals and you can clearly see that they are all pointing in different directions. They're at 90-degree angles of each other, but they all point in different directions. And this helps us with balance and placing us in space and time. Dancers or acrobats, and this is a very important part for them. Here you have your ampulla, and you can see that the ampulla is a little bit of like a bump at the bottom, and this is where the crista is found. And if we zoom in onto the cochlea, here you have your 3 chambers, 1, 2, and 3. And remember, they're all fluid filled. It's either endolymph or perilymph. And here we have, so this has got your endolymph, this has got the perilymph, and here you have your organ of Corti. So we're going to quickly go back. We're going to look at how sound happens.
Have you ever wondered how sounds make their way from the source all the way to your brain? Take a trumpet, for instance. When it's played, it makes sound waves in the air. The outer ear catches the waves, which then travel through a narrow passageway called the ear canal. The sound waves reach the eardrum, which is a membrane roughly half the size of a dime. They make the eardrum vibrate, which in turn vibrates 3 tiny bones called the malleus, incus, and stapes. These bones amplify or increase the sound vibrations and send them to the cochlea. The cochlea is shaped like a snail and is the size of a garden pea. It is filled with fluid, and the sound vibrations make this fluid ripple, which creates waves. Hair-like structures called stereocilia sit on top of hair cells and are grouped together as hair cell bundles inside the cochlea. The hair cells inside the cochlea ride these waves, and the hair bundles are moved. The hair bundle on top of the hair cell turns these movements into electrical signals. As the hair bundles are moved, ions rush into the top of the hair cells, causing the release of chemicals at the bottom of the hair cells. The chemicals bind to the auditory nerve cells and create an electrical signal, which travels along the auditory nerve to the brain. Different hair cells respond to different frequencies of sound. The hair cells at the base of the cochlea detect higher-pitched sounds, such as a piccolo or flute. The hair cells toward the top of the spiral detect progressively lower-pitched sounds, such as a trumpet or trombone. At the very top or apex of the spiral, the hair cells detect the lowest pitched sounds, such as a tuba. The auditory nerve carries the electrical signal to the brain, which interprets the messages as sounds that we recognize and understand.
All right, so you don't need to know all the details about the neurotransmitters and where in the cochlea the different frequencies are heard. You just need to know the pathway of sound. You need to know how the ear hears, starting from the source on the outside of the ear and then how the sound waves travel through the ear. That's all you need to know. And you need to know that it's the brain that interprets the sound wave, that electrical signal, and you interpret it as a sound. So who can remember when the brain will sound be interpreted? What part of the brain will be responsible for interpreting sound? Remember, the cerebellum is for balance or movement coordinating. So where in your brain will you hear? Where's this, the center of hearing, the auditory centers focused? All right, so the auditory location is in your cerebrum. This is where all 5 senses are interpreted, is in the cerebrum, the right or the left hemisphere. The cerebellum is responsible for balance and coordinating movements. So we've got the inner ear sorted now. Remember, you just need to know the structure, the semicircular canals, the organ of cochlea and the cochlea. That's all you need to know. Let's look at how we hear sound. So first, the pinna, your ear flap, your earlobe, traps and directs sound waves into the auditory canal towards the tympanic membrane. Then the tympanic membrane vibrates as the sound wave strikes against it. And if you've ever looked at a speaker or you've taken the front cover of a speaker, that speaker moves as it transmits sounds. The similar thing happens to your eardrum. It vibrates at different frequencies. Then the vibrating tympanic membrane causes the ossicles to vibrate. And the reasons the ossicles vibrate is because the hammer lightly touches the tympanic membrane. So when the tympanic membrane vibrates, the hammer, the anvil, and then the stirrup will vibrate as well. So the hammer, anvil, and stirrup amplify and transmit the vibrations to the oval window. Amplify means they make it bigger. They make it bigger. The oval window is smaller than the tympanic membrane. And as a result, the pressure increases, causing the sound to be amplified. So your oval window is smaller than your tympanic membrane. And whenever we try to take a wave that comes from a larger source to a smaller area, it will be amplified. So the pressure increases, causing the sound to be amplified. And then the vibrating oval window causes pressure waves to travel through the endolymph in the cochlea. Now remember, endolymph is that fluid, and if you drop something in fluid, it will send out ripples. If you have an old speaker at home, there's a really cool activity you can do to test this. You mix cornstarch with water and you make oobleck, or a non-Newtonian fluid, slime, and you put the slime on top of cling wrap, and the cling wrap is on the speaker. And depending on the vibration or depending on the type of sound, the oobleck will bounce at different speeds. This is very similar how it works. The vibrating oval window, so it's like the speaker vibrating, causes pressure waves to travel through the endolymph in the cochlea. So there's one more slide left to show us what happens inside the cochlea. I'm going to leave this on here for a little bit. I see there are 2 questions on the chats, so I'll quickly have a look. Oobleck is from Dr. Seuss, yes, but you can make oobleck. It's just cornstarch or maizena mixed with a bit of water. And you mix it until it's like toothpaste. All right. Let me first ask, can I go to the next slide? Can we move on to the next slide? Yep. All right. So So the organ of Corti, and you just need to know the function, is in the middle chamber of the cochlea, and that is stimulated. So remember, you've got 3 chambers. You've got the 3 chambers, but the organ of Corti is in the middle chamber, and that is stimulated. And that stimulus is converted into a nerve impulse. Now, we remember that we've learned all about neurotransmitters, and neurotransmitters are biochemicals that is used to transmit an impulse from an axon to a dendrite. So the stimulus, the sound wave, is converted into a nerve impulse. And that nerve impulse is then transmitted to the auditory nerve, and the auditory nerve takes that nerve impulse up to the cerebral cortex. So the auditory nerve transmits the impulse to the cerebrum for interpretation, and that your brain interprets the sound and you hear, in inverted commas. So there's still pressure waves though. Remember that still needs to be absorbed. So the pressure waves in the cochlea are absorbed into the middle ear through the round window, and it exits the body via the eustachian tube. So the pressure waves in the cochlea are absorbed into the middle ear through the round window, and it exits the body via the eustachian tube. Right, so let's look at the pathway of sound. So you've got your sound source here. I mean, if you speak, it's your vocal cord. Sound travels from that through the pinna, or from the pinna, it's directed to the auditory canal. It vibrates against the tympanic membrane, and then you have your hammer, your anvil, and your stirrup that is also vibrated, and the sound is amplified. Because the oval window is smaller than the tympanic membrane, the sound wave and the pressure, it is amplified again, the wave. Then it travels down the inner ear to the cochlea, and inside the cochlea, you have your organ of Corti, and inside the organ of Corti, it is transmitted into a nerve impulse, and from there, it is taken to the brain. The pressure is absorbed here. It moves through the round window to the eustachian tube. So it's absorbed through the round window, and then it goes into eustachian tube and out the ear. So that is the process of hearing. That is how we hear sound. Now, in the video, they showed you that the different parts of the cochlea can interpret different wavelengths or different tones. And that's why if you go for a hearing test, they will play you things at different pitches to see if you are within normal range. So we have watched this just now. So there's some questions for us. So the diagram below represents part of the human ear. Identify parts B, C, and D. What is parts B? What is part C? And what is part D? And don't worry about spelling for now. Don't worry too much about spelling. That C has got a very interesting way of writing the word. So what is B? What is C? And what is D? And then explain to me how A and D is adapted to amplify the sound. So to make it bigger or louder, how to amplify the sound. And then say one advantage of your middle ear being filled with air. Remember, this is your middle ear. You don't have any fluid there. There's no perilymph or endolymph in the middle ear, only inside here. So I'm going to leave that on there for a little bit. Let's see, I've got a few answers already. Well done, gosh. All right, so B is part of the inner ear. B is the semicircular canals. B is the semicircular canals. C is the eustachian tube. This is what takes the pressure out of the inner ear. And then D is over here. D is the oval window. So if we look at how sound travels through the tympanic membrane, up the hammer, anvil, and stirrup, it vibrates against that oval window and then it's transmitted into the cochlea. The semicircular canals help us with balance. So this is the semicircular canals. This is the eustachian tube. Where the pressure is relieved, it leaves the inner ear through the round window. And explain how parts A and D together are adapted. So A is the tympanic membrane. That's the first thing you need to say. It's the tympanic membrane and it is larger. D is the oval window and it has got a smaller surface area. So the incoming sound waves are concentrated on a smaller area. So the sound waves travel through the tympanic membrane, which has got a larger area than the oval window. And because of that, it's concentrated onto a smaller area, it amplifies the sound. So what would have happened if we had fluid in here? If there was fluid, some of the vibrations would have gotten lost in fluid. This allows your hammer, your anvil, and your stirrup, the fact that there's air, to vibrate freely. It helps the ossicles, the three tiny little bones, your hammer, your anvil, and your stirrup, to vibrate freely. I'm going to leave that there a little bit. Now also, we'll learn tomorrow that if you have fluid buildup here, you are very prone to get middle ear infection. If you get middle ear infection, then it will hamper your hearing and it will also continuously just flow down your eustachian tube. But what the advantage to it is, it allows those three little bones to vibrate freely. There's nothing that inhibits the vibration. If there was fluid, it would flow freely, but it will also absorb some of the sound waves. All right, next up, we have a diagram of the middle ear. We've got a diagram of the middle ear, and we know that because I see the three ossicles and I see the eustachian tube. So identify A, B, and C. You can use the Latin name for B, or you can just use the normal English name. And C points to the opening, not to the stirrup. All right. Yeah, Bob, well, that is why sometimes, well, your nose and your throat is also connected. And most of the time when you swallow fluid, it's more from your nasal cavity or your sinuses. If you have middle ear infection, though, it can spread to your throat. So if we swallow, it's from the fluid from the nasal cavities and your sinuses, not from your ear. All right, let's look at the answers. So A is the tympanic membrane, your eardrum. B is the incus or the anvil. And C is the oval window. So give the letter of the part that absorbs sound waves. That's the round window, D, it's the round window. And it prevents you from getting an echo. And then E is the eustachian tube. And when that is blocked, you have a middle ear infection and it will temporarily lead to hearing loss. You might not be able to hear that well if this is infected. All right, so I've prepared a little Kahoot for us, and I think there's just about enough time just to go over the parts of the ear and hearing. So I know you know the drill. This is a short one, and hopefully our host will entertain us and participate. Ooh, you just turn down that sound. Kahoot really needs to maybe put some rap or some, decent music as their background. More people would enjoy it, even more than they do now. Hi, Boomer. Hi, Bob. Hi, Kaylendry. Come on, girls. I know that you want to. I'm going to wait until there's at least 4 people. At least 4, hopefully 5 to participate. Oh, well done. Thank you, Tobani. You're such a sport. All right. So I am going to see here if there's any sound. Power's out. Oh, I'm so sorry. Oy. Yeah, we've been having problems with our electricity as well. I really hope load shedding is not back. In wintertime, load shedding is going to be very difficult. All right, so let's start then. So if I see all 4 of you answered, I'll just skip. So 1 pointed to the outside ear. All right, that is known as the pinna. That is known as the pinna. Well done. Goodness, that was fast. So 3 is in between the inner ear or the middle ear and the outside. Too easy. Too easy. I think it's today going to be about who's got the fastest reflexes because you're all doing so well. Like puzzles. I like that question. It was very funny. Yeah, we're halfway. Almost halfway. 8 would be. Oh, this is a tricky one. This is a tricky one. Well done. Table 2. All right, so that was the first, it was the first bone, and the first bone right after the eardrum is the hammer. So 3 is the middle bone. It's the anvil. Always think of the hammer hits the anvil to make a stirrup. Has. has hammer, anvil, stirrup. Well done, Bob. You are on fire. So remember, hammer, anvil, stirrup, has. Great. Ooh. 14. 3 questions left. The malleus. So only one of them is actually a bone. It's the incus. And the last one, guess what the question's going to be? It's the stapes. It's the stapes. Malleus, incus, stapes. Has or miss. And that's it. So let's see. Oh, congratulations, Kahoot. Congratulations. Oh, okay, so that was it. I'm going to quickly exit the Kahoot. So tomorrow we'll be looking at balance, and we will be looking at exam style questions, and we'll also look at defects or problems with hearing. So it's either the middle ear infections, people who keep on getting them get grommets because it helps the ear to drain. And then we'll also look at a cochlea implant and how they work. And this is just for a little bit of information for you. There are some questions in the exams, and then we'll answer exam style questions as well. So do you guys have any questions? Do you have anything you'd like to know? I have some news to share with you. All right, so my school starts again, and I'll have to go back to school because I'm part of the like the senior team, or people who HODs and people who have to plan. So I'm back at school on Monday. Just to help with setting up if we go back. It's all up in the air when or how, but there's a lot of planning, and you'll have a new teacher. I will, however, keep that Twitter page. I made it especially for you guys. You are so special, so I made it especially for you guys. And I'll keep the Facebook page. Well, I always have the Facebook page because my old students from different countries sign in there. But if you have any questions, please let me know. Please let me know how you've done in your exam. I've known 2 or 3 weeks is nothing compared to a year, but I really would like to know what happens, and if you go study, and where you study, and what you are going to study, and just a little bit, yeah, let me know how it goes. I know that all of your futures are so bright. You need to wear shades. You are all very eager to learn, and you're so dedicated. And in life, a willingness to learn and dedication will bring you much farther than just being intelligent. So if you are bright like you are dedicated, and you are willing to study, the sky's the limit. So tomorrow is our last lesson together. I'll put the video on just because I haven't spoken to you on video before. And we will look at balance, and we'll answer exam style questions, and we will look at how grommets work, and what's middle ear infection, and hearing loss, and why some people, you only lose in one ear, and how it works. So yeah. Any questions you have? I know, I'm so heartbroken, but I will be on Twitter. I will be on Twitter. I'll be more active on Twitter. And I really want to know how you guys are doing. So please let me know on there. I'll keep that page open just for you. And go to the Facebook page and add me. It's Miss Lizelle van Wyk. And tell me how you'll be. And Miss Mel will still be here. And I think the Twitter is, as I said before, it's my name and numbers. Oh, Mrs. So add me on either Twitter or I already told the new teacher to do Kahoots, and I am having a little Teams meeting with her over the weekend to show her how Kahoots work and how she can set up Kahoots and how she can make her own Kahoots. So don't worry, Kaylin, you'll still do Kahoots. I know how much you like them. All right, guys, if you have any questions, please, please, please leave it here. Otherwise, I'll see you tomorrow and we'll have a little goodbye. Oh my gosh, I'm quite sad. All right. I'll stay here until all of you have left, and then Miss Mel and I will leave. So we are always here right till the end, in case there's someone who changed their mind about questions. Have a lovely day, guys.